Hey everyone, welcome back to our channel. Today, Amir joins us to continue the discussion about Fabric Data Science samples ready for use. The last time, in the previous video, Amir has presented a great detailed demo about doing the prediction, the forecast. And I'm just wondering what samples do we have for today?
Thanks, Esther, for having me for another time. It's my pleasure to join you again to walk you through another of our data science and AI samples on Microsoft Fabric. So today, another sample that we want to walk through is about customer churn sample. This sample has been out for a while and it has resonated very well with our customers because of the use case scenario. I think many of their customers want to know that what is causing some of the customers to actually start doing business. So this sample is actually walking you through end-to-end and step-by-step through getting the data and doing some exploratory data analysis and train different machine learning models and then log them and pick the one that actually predicts which of your customers would actually start doing a business and churn. And this is a sort of very, very useful use case scenario that I'm going to demo in a few seconds.
Can't wait to see this. Churn analysis is something what every online business is caring about if they want to make sure that the service they are delivering is on top of the quality. So can't wait to see it. Also because the demo is packed with some great unique features, from installing the libraries to doing some great visualization. Let's see it.
Yes, let's do it. The scenario is to build a model to predict whether bank customers will churn or not. The churn rate, which is also known as the rate of attrition, refers to the rate at which bank customers stop doing business with the bank. While in this notebook, we try to build a churn prediction model for bank customers, I'd like to mention that churn prediction model is applicable to any business. Actually, churn prediction model is a very important business problem because it actually helps businesses foresee when customers might leave, so businesses can actually focus on efforts to keep the customers happy and hence staying profitable. Now let's go through this notebook together. The first step in this notebook is to install custom libraries. You might ask, why do we need to install custom libraries? And I will explain that in a few minutes. But generally, when developing a machine learning model or doing ad hoc data analysis, you may need to quickly install a custom library. And in this notebook, we actually need to install IMBlearn. To do that, in Microsoft Fabric, you have two choices. We can use the inline installation capabilities such as pip and conda, and that would get you quickly started. But note that would only install the custom library in your current notebook and not in your workspace. So if you need these libraries in another notebook, you still need to install them. Alternatively, you can create an environment and install custom libraries from open sources or from your local files in your environment. Now in this notebook, as I mentioned, we will need IMBlearn and we're going to use pip install. Again, note that you need to do the pip install at the beginning of your notebook and as your first cell, because that would actually restart your kernel. So let's actually do the pip install IMBlearn. As you're waiting to pip install the library, let's actually take a look at the data. So our data set actually contains around 10,000 customer data points with around 14 attributes or features, which include the credit score, the geographical location, whether it's Germany, France, Spain, the gender, which is male or female, age, tenure, the account balance, the estimated salary, the number of products that the customer has purchased through the bank, the credit card status, and active member status. The dataset also includes some other columns such as the row number, the customer ID, and customer surname, which we don't believe have any impact on customers' decision to either stay or leave the bank. The event that defines the customer churn is closing of the customer's bank account, and there's a column named exit, which actually refers to the customers leaving the bank. As we are looking at, we have realized that out of the 10,000 data points about customers, only 2,037 customers, which is roughly around 20%, have left the bank. So the ratio is 80% have stayed with the bank versus 20% have left the bank. So that already tells us that our data set is imbalanced. And that again gives us some hints that we may need to generate synthetic data. This also shows a table and preview of how our data looks like. You can see that customer ID, surname, credit scores, and all of the features or attributes. And we also have the target column exited, which refers to the situation where bank customer have stayed with the bank or have left the bank. Now let's look up. Well, we can see that in almost like 30 seconds, we have been able to pip install our custom library IMBlearn, and shows all done. Okay, great. We install IMBlearn, and as I said, you might ask why actually we need to install a custom library. So I think you might have noticed now that we have an imbalanced data set. 20% versus 80% for the customers who have left the bank versus who have stayed with the bank. So the problem with imbalanced data set is that the classification would become challenging because there are too few samples of the minority class. In this case is the class of the customers who have left the bank. So it would be difficult to effectively learn the decision boundary. Now, one of the solutions, or one of the common solutions, is to use a technique called smooth, referring to synthetic minority oversampling technique, which is very widely used. And it's basically aiming to synthesize new samples for the minority class, which is again the class here referring to customers who have left the bank. And the way to actually access smooth is through IMBlearn. So if we go back up, the reason that we actually did pip install IMBlearn is that we want to actually access smooth, and that's why we install IMBlearn. So we have done that, and we can set some parameters in this sample, which basically where is the data root, which is the folder, what's the file name. We can decide, you can set some parameter to decide whether you want to use all of your data for training or you want to use a sample of that. So let's just run that. And the data is already existing on some blob storage. So we're going to download the data from some blob storage and actually upload it to our lakehouse. And this is actually our lakehouse here. So one lakehouse is already added here. So our data is also now in lakehouse. You can see that it has run. It's great. So we can also actually take and measure the time that it takes to run the notebook. It will take a little longer here because we're going to go step by step through some explanations, but it always helps to actually measure how long it takes to run a sample or run a notebook. Okay, so as I mentioned, our data is in our lakehouse. So we're going to actually now first actually read our raw data from our lakehouse. So I'm going to click on this one. It would be a Spark data frame, and that's fine, there's no problem. But generally, sometimes it's easier for visualization and processing purposes to deal with, let's say, Pandas data frame. Again, that's not a limitation. You can always do any sort of processing or visualization on Spark data frame, but it's sometimes easier. So while our initial data set is a Spark data frame df, we actually want to convert it to a Pandas data frame. So we actually do df do dot to pandas to convert our Spark data frame to a Pandas data frame. And as you can see, in 3 seconds, all done. Okay, so now we have our raw data in a Pandas format. The next step is actually to perform some exploratory data analysis. For any data science or machine learning project, one of the most time-consuming, or I would say even tiresome steps, is actually going through the exploratory data analysis to like clean the data, deal with missing values and all of that. But first step, we actually need to import some libraries, for any visualization and all of that. You need some common libraries such as Seaborn or like Matplot, NumPy, and Pandas. So we're gonna actually import some of those libraries. Again, you can see that that's done very quickly on the notebook, less than almost 11 seconds. So now let's actually take a look at our Pandas data frame. So this is display. We're going to take a look at our data frame and get some statistics. So it actually shows all of the columns. It shows the type, the number of unique values, the number of missing values. We can also click on each of them and get some sort of a statistical view here. Okay, for example, for the column balance, it shows some sort of a histogram, and we can do it for age. We can also do the number of products, estimate the salary. It's actually very helpful and help us to get some good statistical view of our initial data set. Now for next step, we actually want to do some sort of data cleaning and data transformation. We have a very good feature at Microsoft Fabric Data Science Notebooks, which is called Data Wrangler, which allows you to actually perform some sort of data cleaning and data transformation. To do that, we actually go to the data here, and then it says transform data frame in Data Wrangler. So you're going to click on that, and it actually shows you the available data sets that you have. And it could be Pandas data frame, or it could be a Spark data frame. Here we are having Pandas data frame. So I'm going to click on df, and it would actually open for me the Pandas data frame in the Data Wrangler. First of all, it actually shows me sort of some overview of my data, the different columns and all of that. For the first step, I want to, for example, drop duplicate rows. You see that here on different operations we have, and then you can click on each of the operations. You can see different sort of operations it performs. But first of all, I want to basically drop duplicate rows. So I'm going to click on that one, and then it asks me to select which columns I want. Here I'm going to select row number and customer ID, and then I'm going to apply on that one. And you can see that it's actually generating the code for me that shows that one. So drop duplicate rows here. So you actually create the code for me for that one. So that's the first step. Now I actually want to do more on that one. So I also want to, for example, drop rows with missing values. So I'm going to click on drop rows with missing values. Now this time I actually want to do on all columns. So I want to select all, and then I'm going to click on apply. And you can see that again is generate the corresponding code for me. And each step that I'm doing, you can see the first step was actually loading the data, the one like dropping the duplicate rows, and then dropping missing values across all columns. For the last step, I'm going back again. I actually want to drop some columns which I think they're not very useful. So I'm going to actually schema here, and then I'm going to say drop columns. And actually I'm going to select again some target columns that I wanted to drop. So I'm gonna look at, for instance, it would be row number, customer ID, and surname. These are the columns that I don't think very useful. So again, I'm gonna do that. And then you can see that it's gonna show me the preview here, and it actually generate the code for me. So you can see that it's already generate all the code for every steps that I have done. I think I'm sort of pretty much done now here. So now that I have done some sort of cleaning, again, I have dropped duplicate rows, I've dropped missing values, and I have dropped columns that I don't think are necessary or basically are redundant. Now I want to actually add all the generated code to my notebook. So I go click on here, add code to notebook, and it would actually generate some code for me. So you can see here, it says like code generated by Data Wrangler for Pandas data frame. And it actually has that. So drop duplicate rows, these are the rows, drop rows with missing data across columns, drop columns, the space columns, and so now I've got some sort of like a clean data. Okay, great. And you see that through screenshots here, it actually shows all the process. So if you look at this one, it actually like explains you step by step to what you do. So we have now a clean data. And again, it's pretty quick now. If you remember one of the parameters I defined above here, it was like, okay, do I want to use all of my training data, or I want to use like a sample of my training data, which I assume that I want to use all of my data for training. So what we also have here, if I go down, that says like if you want to, I'm going to use a specific number of data points for training. Okay, so I've done that. So I think I've like somehow cleaned my data. Now I want to do some sort of visualization. First of all, let's determine what are my target variable, which is the exit column, and I want to like decide what are my categorical and numerical features. So let's run this one. Okay, I see that exited is actually my target variable, or like the variable that I wanted to actually predict. So these are my basically categorical attributes or features, which is geography, gender, number of products, whether it has a credit card or not, and whether it's an active member or not. And these are my numerical features or attributes: credit score, age, tenure, balance, and estimated size. Okay, great. I'm getting to know my data set better and better. Now let's look at the 5-number summary. So I have a code to actually show you the 5-number summary. Let me run it, and great, less than 2 seconds. Okay, now I'm getting to see the minimum score, the first quartile, the median, the third quartile, and the maximum score for my numerical features or attributes using box plot. So I can say credit score, what is sort of the median, the max mean, the age. Okay, I can see that like the median of age is like somehow in late 30s, I would say. The tenure, the estimated salary, how much is that, the balance, and all of that. So it's actually giving me a sense. This is actually very useful because, for instance, I can see that the age, we have some sort of, we might assume that it's like outliers, but actually it helps me think that is it actually an outlier, because it might seem like an outlier because out of range, but when you think more, you actually realize that, well, banks have customers that are like above 90, so you cannot necessarily like consider these as outliers and drop them. So it actually helps you to actually gain some good knowledge, and we always recommend to actually perform EDA or exploratory data analysis, but it gives you very valuable insights from your data set. Now let's actually look at the distribution of exited versus non-exited customers across some of the categorical attributes. So these are my categorical attributes. So I can see that, okay, for example, across geography, I can see that, for instance, Germany probably have a higher number of customers who have exited. Or at the same time, I can see that, for example, like France has the lower number of customers who have left the bank. I can also, for example, look at the exited versus not exited for customers who either have a credit card or they don't have credit cards. I can also look at, for example, the gender. And this is actually very useful because it actually can tell me that is there some sort of a correlation between, for example, the gender and whether they have left or not, and like whether for across different like features. So this also helps me to getting some further insight. Now I'm actually going to look at the distribution of numerical attributes. So I'm going to run the code, and again, in pretty quickly, in less than 2 seconds, I get that. So I can look at the credit score. I can see that, okay, we have some sort of like, let's say average around like 600. The age is roughly like 30 to 40. But again, you can see that we have some age at here, and we cannot necessarily assume these are like outliers, you know, the real customers who have age of like 80, 90 and whatsoever. I also have some balance and all of that. So again, it's getting me a very good knowledge about how my data look like. Do I need to consider outliers, or those are not really outliers and whatsoever. Great. So we have done some sort of a data analysis. Now, if you look at all of these, you can see that like across many of these features, there are different like ranges, you know, while like, for example, credit score is between, let's say 0 to 800, the age is between like 20 to like 90, the salary is like from 0 to like 2000, you know, 2000 or whatever. So there are different ranges, and to help actually my training model, it would help to actually kind of normalize them, to kind of keep them from different ranges to more or less a similar range. So I'm going to do some feature engineering, and I'm going to have, let's say, a new tenure, new credit score, new age score, and all of that to kind of like perform some feature engineering, kind of normalize them to bring them to some more or less the same range. Okay, great. So I think up until now, it seems like we have done some data cleaning, and then I have looked at my data, and I have done some feature engineering. So like they are more or less on the same range. I realized that I have some categorical features, and sometimes machine learning models may not work very well on categorical feature. So I want to do some sort of a one-hot encoding. Again, I'm going to use Data Wrangler to do that. So again, I'm going to go here to data. I'm going to like click on here. You see now we have more data. Now we have the clean, we have the DF and all of that. And again, now this time I don't want to work on DF, I want to work on DF clean, because that's a clean version of data that I had, right? Because all of this processing that we did here is on DF clean, not on DF. DF is sort of our raw data that we have. Okay, so now I'm going to click on DF clean, and then I want to, for instance, look for one-hot encoding. So I can, again, you can see that we have different operations that you can do. For example, here I want to do a one-hot encoding. So I'm going to click on one-hot encoding, and then again, I want to decide which features. So the only two features that are applicable for one-hot encoding here are geography and gender. So I'm going to click on those ones. You can see that. You see sort of a preview. I'm going to apply that one. And again, you see that has created the code for me. Again, all the steps that I have done is shown here. That's the only step or the operation that I wanted to do. So I've done that. I want to add the code to the notebook. Okay, you can see that. Again, code generated by Data Wrangler for Pandas data frame. It takes the clean data and it now performed the one-hot encoding for me. So now I have that one. Okay, great. So now I also have the one-hot encoding for geography and gender. Okay, I have a clean data. Now I want to actually save my clean data to my lakehouse. So I actually have a copy of my clean data to my lakehouse. So actually, like, you know, I'm saving it to a table named like df clean. So it's going to be actually in my lakehouse. Okay, great. So we are done with that one. It should take a few seconds. So done. Okay, 16 seconds. Also, let's kind of quickly review some of the observation that we had from data analysis that we had. So we realized that most of the customers are from France comparing to Spain and Germany, but we also realized that Spain has the lowest churn rate comparing to France and Germany. We also realized that most of the customers have credit cards. We realized that there are customers whose age and credit score are above 60 and below 400, but they cannot really consider as outliers or real customers. We realized that very few customers have more than 2 of bank's products, and customers who aren't active have a higher churn rate. And it seems like gender and tenure don't really have an impact on customers' decision to close a bank account. Great. So now we are getting to some, let's say, more exciting part, which is like model training. So we have the data, we have actually the clean data in place and all of that. So we're going to train a model. For this notebook, we're going to use two models, scikit-learn and like GBM, and then they're very easy to implement in Microsoft Fabric Data Science notebooks. And we can also to kind of use MLflow to actually log all of the experiments that we are running. So let's run this one. I've saved my clean data in my lakehouse. Now actually I'm reading the data from my lakehouse. And now I want to actually start generating an experiment. So I'm setting up a experiment name, which is like sample bank churn experiment. So when I go to my workspace, this would be actually the experiment that I'm running. So I'm going to actually like run this one. Great. Before we move forward, what is actually MLflow? So when you're training different machine learning models, you know, traditionally you may need to have like a pen and paper to track like what experiments you run, because you have different parameters that you might be tuning. You might like different like metrics for which you are actually assessing your machine learning model. So as you train more and more different models, it would be very difficult to keep track of that. But we have like MLflow auto logging capabilities in Fabric that actually automatically log all of these sort of parameters for you. So you don't need to keep like tracking them manually. Like you can go to your experiment and your model logs, and you can easily say that, okay, you have run this model and these are the parameters that you use to train this model, and these are the results of your model training. For instance, like these are the metrics on which you assess the model. So we have done that, and now we're going to actually like set up the MLflow and all of that to auto logging. So as I mentioned, we're going to use two different models. One is like random forest from scikit-learn, and the other one is like GBM. Now I need to import these two libraries. And I also need to, for example, do the train test split, and I also kind of need to import some of the metrics that I want. For example, accuracy score, F1, precision, confusion matrix, and all of that. Great. So as you know, the very first step in any machine learning model is actually to split your data to train and test. So you know that the df clean is our clean data. I'm gonna like split that to the train and test. Done that, I'm going to use a ratio of like a 20%. So 20% goes for test data and 80% goes for training. Now here comes the smooth. So again, if you remember from the very beginning, we installed that IMB-learn because we wanted to have access to a smooth. Why did we want to access a smooth? Because we mentioned that our data set is imbalanced. And for imbalanced data sets, to better and more effectively learning the decision boundary, you may need to actually generate synthetic data. And one of the ways, or commonly used ways, is using a smooth. From IMB-learn, I'm going to import a smooth, and actually I'm going to apply smooth to my data. Again, bear in mind or note that you only apply smooth to your training data. The test data set is untouched data set that you just want to actually evaluate your model on that one. So you just apply that one on your training data. So again, I import IMB-learn. From IMB-learn, I import like a smooth, and I apply that on my training data. Great. So it's running, and then again in less than 13 seconds, done. Okay, great. Now I want to move to next step, which is actually model training. As I mentioned, I'm going to train 3 different models, 2 random forests with different sort of parameters and 1 like GBM. The first random forest is going to use a maximum depth of 4 with 4 features. You can see that it's run. So the name of the model that I'm going to do, the experiment name is specified here, sample bank churn experiment, but the model that I have, the name of the model is like RFC1_SM, and it's gonna again automatically log all of the parameters and all of that. So I'm gonna run this one very quickly. It's running the model, it's training the model using the random forest, as I mentioned with that. Okay, in 20 seconds is done, and as you can see now, RFC1_SM is actually the model name, and if I actually click on that one, you can see that it takes me to experiment now, and it actually shows all of the details, all of sort of the parameters that have used and all of the results of that. Okay, going back, now I want to actually train another model. This time I want to train a random forest with a maximum depth of 8 and 6 features. I'm going to run that one. Now the model name that I've selected here is RFC2_SM. Again, it would take probably around like 20 seconds, similar to the other one, to quickly run this one as well. Again, the benefit and like the good thing about it is that you don't need to worry about tracking the parameters or like the scoring metrics that you have used. All of them will be automatic log, which is very useful because in real use cases you want to train many different models, and that enables you to easily track all of them. Again, you can see that it's all done, and now this one is like all of the parameters associated with this model is being saved here. I'm not going to go there, but you get the idea. Now finally, I want to train a light GBM model. These are the parameters that I have set. So I'm gonna train a light GBM model. Very easy. And it first kind of registers the trained model with auto logging and all of the parameters. For example, I have the number of estimators I've selected is 100, the maximum depth is 10, and again 13 seconds, done. And this one now is save under the name LGBM_SM. Great. So I'm done with my model training. I've trained three different models, and I can look at all of them and then see what happens. And you can see here, for instance, it actually shows, I have different models and all of that. You see in real world, you actually train many different models, and you can actually go to your workspace, and then you can select an experiment name, which is here is sample bank churn experiment, and you can see all of the models under different names, and then you can see the accuracy, the specific parameters for each model, and all of metrics, and you can easily track. And then you can, for instance, okay, this is the best model that I have trained, and I want to move forward with this model. Great. So I want to basically save all of these models, because I want to test on all of them and see how it happens. Pretty quickly, I'm getting the run ID from above and then done. Okay, now I have three different models. I actually want to assess or evaluate the performance on the test data set. So you can see here, I'm using the X test, which is actually my test data set. This was not shown to my model during the training. This was a test data set was set aside just for testing. Great. So I'm going to run that one, and I'm going to assess the performance of the saved models on the test data set. Done. Let's review what we have done. We trained a model, three different models with different parameters. We assess them on the test data set that we have saved. It's an unseen data. For next step, we're going to actually plot a confusion matrix, which is actually help us to kind of evaluate the accuracy of the classification. So we have written the code that helps you to plot the confusion matrix. Now I wanted to actually plot the confusion matrix for all of these three sort of trained models on the models that have been ran on the test data set. Okay, so I'm gonna do it first for my random forest. You can see here the prediction is coming from RFC1 underline SM, which was my first random forest. Now I'm gonna do it for my second prediction, which was coming from RFC2 underline SM, and the last one, which is coming from my light GBM LGBM. Okay, so now I got the confusion matrix for the three models that I have evaluated on my test data set. Great. And now I actually can evaluate and say, okay, which model is doing the best and all of that. I've selected that one, and I can save the best model, or I can save all of the models to my lakehouse. So I've decided to actually save all the results from random forest version 1, random forest version 2, and light GBM to my lakehouse as a table. So I've saved that one, and sort of you're done with machine learning model, right? So we have trained a model, we have tested the model on the test data set, and now I have saved all the results to my lakehouse. Now, one of the challenges that you have in very machine learning models or machine learning projects is that it kind of ends here, but that's a good thing, right? So what is more important is actually how you can actually translate these insights that you get from machine learning model to actually business insights. Because if you remember, when from the beginning we said that we are talking about churn prediction model, to train a model to make predictions about churn of your customers, but then how can I actually evaluate and translate that to some business insight that actually help me take some actions to improve the business to make it more profitable. So now that we actually have saved all the prediction results to the lakehouse, I can actually import it to a Power BI. I can go to the One Lake Data Hub, which I'm not going to go through the details here. The instructions are available here. You can follow here. And actually I can create a very nice Power BI report and dashboard, which can actually give me some insights as to, okay, what is happening. And again, this is just an example, a very accurate Power BI report and dashboard requires insight from business people and all of that. But for instance, what we can see here is that customers who use more than 12, the bank customers have a higher churn rate. So for example, this suggests that the bank may need to collect more data, but also investigate other features correlated with more products. Why customers who have more than 2 products have a higher churn rate. We also see that, for example, the bank customers who are in Germany have a higher churn rate than in, for example, France and Spain. Right? For instance, this plot shows us. So this is again an insight that, okay, what is happening? Is this a more competition in Germany or whatsoever? So you see, these are the insights that you actually get from the prediction, which is imported to a Power BI, and now that would lead to taking some business actions. and so on and so forth. And then finally, you can actually take time to see how long it takes. Obviously, this is not accurate because we have been pausing to going through step by step. But basically, this captures how you can actually build a churn prediction model in Microsoft Fabric Data Science notebooks. Again, this was very specific for bank customers, but it's applicable to any use case. And this is a very valuable use case.
The demo is phenomenal. It's super advanced. And I love especially the integration with Power BI, as the final report looks super impressive.
Yeah, so I think one of the distinct features of this sample is actually, in machine learning and data science, usually after you build a model, things end there. But what we try to kind of do in this sample, take it one step further, and actually, when you have trained a model, you have got the predictions. You actually import those predictions into Power BI to actually gain some actual business intelligence value and show through a Power BI report about what are the type of customers that would actually churn, from which country the customers that are churning more, and all of that. So then, in this case, banks or any of your business could actually leverage those information to take actions to actually reduce their churn rate. So we're trying to show an end-to-end that a machine learning model can actually lead to very impactful business actions that help the businesses.
Phenomenal. Just to emphasize for those who are watching us for the very first time, what are the prerequisites to try the samples?
As with all of our samples, you don't need to do much. You just need to go to Microsoft Fabric, have a trial account, and then just select Data Science, Synapse Data Science, and then use one of the samples, and that's it. Not much. Pretty easy, I would say.
Yeah, notebook, everything is pre-provisioned for the use.
Yeah,
And also no need to configure any execution engine like Apache Spark because it's ready for you.
it's already. You just need to run the notebook, and you get all you need.
Fantastic. So I can't wait to try it on my own because watching the demo is one thing and trying to run cell one by one and read all the comments, it's the next level of exploring these capabilities.
Please try, and then if you have any questions or if you have any comments, please let us know. And as I always says, we're always open to your feedback. If you think there are ways that we can even make the samples easier for you, or make it more clear, we are always open to your suggestions, and we strive to make the samples better and easier to follow.
Super. So let's wrap up today. And for our viewers, if you enjoy it, leave a comment, hit the like button, subscribe, leave some suggestions, reach out to us with also the feedback. And until next time, happy discovering this customer churn sample. And for the next time, let's see what else we have in the box of data science samples. Thank you.